Yeah, so our next speaker is Ian Hobson. Hello, Ian, are you here?
Hello, can you hear me?
Yeah, so yeah, so thanks, Francesca, for this talk. So we talked already about, I guess, several programming languages already, but this is a programming language special, so we're going to talk about more programming languages. And the next one is going to be Rust. So Ian, obviously, so first of all, you're a former DSP principal at Ableton. Now you're an independent developer, but also I remember that you've given several talks at ADC. So you're kind of a regular speaker there. And the last talk I remember from you, which I think was in 2018, was about Rust and how to use that for audio. And I think at the time I was really excited about that because no one was really using Rust for audio as far as I was aware at the time, or at least not in a way that the community would be aware of. And you kind of gave a talk about how to do that. And I found that very interesting. Obviously, that was several years ago. So things have changed since then. So you're still doing Rust. And yeah, I'm really looking forward to hearing where we are with Rust in audio tonight from you. So welcome, Ian.
Great, yeah. Well, yeah, thank you. And thank you for inviting me to do this. I appreciate it. It's a fun thing to do. I'm happy to be here. So I share my screen, right?
Yeah.
Let's see. Do I do this? Yeah. Yeah, so as Timo mentioned, I gave this talk at ADC a couple of years ago. And that's really my whole connection with Rust. I'm not like a big contributor in the community, or I haven't like released some like large projects in Rust, but my background really was one of curiosity over several years following the Rust project and seeing it develop and to become what I thought could well be a viable alternative to C++ for real-time audio development. Because for a long time, it really felt like C++ was the only choice that we had. Yeah, so anyway, I mean, I was introduced earlier, so I can skip over this. And also, yeah, the talk was called An Introduction to Rust for Audio Developers. And you can go and look it up on YouTube if you haven't seen it and you're interested in Rust in the context of audio. I'm going to skip over a lot of the introductory material. I'd say, like normally in a Rust talk, maybe I'll go through a few of the basics, but we only have 30 minutes. So I want to kind of try and dig a bit deeper into the language. And also, yeah, like Timo mentioned, maybe give an update about what's changed since I gave this talk in 2018. So one thing that's changed is that we've seen a lot more industry adoption. So large companies are paying attention to Rust now in increasing numbers, and like it's quite amazing to see how quickly this is happening, actually. And one of the key things that's come out of this, there are several reports where large companies have looked at all of the security issues that have been found in their software projects, and a consistent number that pops up in these reports is that 70% of their bugs, security bugs, are related to memory safety. And the memory safety being the kinds of errors in handling memory that crop up quite often when you're writing C or C++ code, where maybe you're accessing memory outside of the range which you think that you should be in, or maybe you're accessing an object which has been deleted, or well, there are all kinds of ways you can make mistakes. And yeah, it's a pretty consistent finding that has popped up so far. And something that is really important to take away from looking at Rust is that there are whole classes of bugs which are impossible to write if you're working in safe Rust. And that's really the key differentiator from Rust to other systems languages that came before. And you might be thinking, well, who cares about security, because we're dealing with audio development, and maybe this doesn't matter so much to us. But ethics aside of being sloppy about security, actually the kinds of bugs that we're talking about come up again and again when you're working on audio algorithms, or at least they have in my experience, where I'm running into these types of errors. Maybe you spend a few hours debugging something really hairy and it turns out that an object wasn't initialized correctly, or that maybe like there's some undefined behavior and then the debugging experience is inconsistent. And those kinds of bugs are not so much fun to deal with and to debug. Now, another thing that has developed since 2018 is that Rust has continued its run as the voted most loved language in the Stack Overflow developer survey. So that's 5 years in a row that people have taken this survey and voted Rust as like most loved. And it's a bit of a strange thing to point to, I think, but it's interesting to me because it speaks to this idea that you can actually love a language. I find that quite interesting. Or that if maybe we scale back the term, like maybe love is a bit strong, but like this kind of emotional connection that you get to the tools that you use, I find very interesting. And what does it really mean for people to be like claiming that they feel this way or declaring that they feel this way? And so then I started thinking, well, what is it that I see in this language that I feel that strongly about? And I'm not sure if I would say I love Rust at this point, but maybe we're not at that stage of the relationship yet, but I really enjoy using the language. And at this point, I'm using it full time. So since leaving my work at Ableton last year, I've been able to use Rust as my primary language in all of my work. And so it's been a good run of like 10 months now or so where I'm using Rust full time. And also I've actually managed to get some audio analysis code, like real-time code shipping with Lowfelt as part of the iOS SDK, which I guess you'll hear more about later from Neil. So to highlight some of the aspects of Rust that I like, I wanted to connect some of the ideas to a project that I've been working on. It's an old project that I dusted off. It's a granular synthesis engine, and let's see if I can get it running. And maybe turn up the, right, maybe you can hear this. So granular synthesis, of course, is where you take lots of slices of sound, very short slices from like a larger sound, and then you window them and you string them together to create like time stretching effects or drone-like effects. You can do lots of fun things with it. And it's a really good engineering exercise. So if you haven't implemented a granular synthesis engine before, I would highly recommend it because it's a good fun thing to implement. Anyway, you can mess around with it and find sounds and play around. So, good times with granular synthesis. Oh yeah, and here's an illustration of what's going on. You have a larger sound buffer, and then you take short slices, smooth them out, and string them together. So you have lots of overlapping grains to produce these larger effects. And yeah, I borrowed this from the internet. You can find it here. So that gives us some context for some things that I really like about Rust, or even love. And the first one I want to talk about is the ergonomics of the language. In particular, Rust enums and pattern matching as a core language feature, I think are a really useful, pleasant thing to use like in your day-to-day code. And one that you'll encounter a lot in Rust is the result enum. And what you'll see here is that there are two variants in the enum. And these enums both have a value attached to them. So this is a lot like the stood variant in C++. It's essentially the same concept, but as a core language feature. So when you call a function which may succeed or not, it will return a value, and that value could either be an OK value of type T, or it can be an error of type E. And so then when you're using functions in Rust or a library, often it will be written with this result type as the primary mechanism for reporting success or failure. And in the granular synthesis engine, we need to load lots of sounds from disk. And a load sample function is the main entry point for this happening. It returns a result, and the result is either a vector or a dynamic array of stereo frames. So we're going to create a stereo sample of a particular format. And in the error case, we're returning a string, which will have some information about what went wrong. And inside the function, we're calling an open function on WAV-reader, and we'll come to that later. Passing the path, and if it was successful in opening the path, then we get a reader as the OK return value. And unpacking the reader is achieved by using the match keyword. And so match on some enum type, or well, match on any value that can be matched against. And it's not just enums, but for now, we'll just deal with enums. You get the OK value or the error value, and then you're able to work with the contents of that particular value type. Now, this is, of course, possible in C++ and other languages. I'm not making a claim that Rust is particularly unique here. It's just that I find the fact that it's baked into the language so deeply, and from the very early stages of the language, that it has a very nice, clean syntax to it, and it becomes very natural to use this style of coding regularly all the time. You end up using it a lot, and that means that it's second nature to use this as a tool. So then another example of matching here is that to load the sample, we want to convert the source material to a particular format. And what we need to do is look at the number of channels in the sound, the bit depth of the sound, and the sample rate, and then, well, not the sample rate, the sample format, sorry, whether it's an int or a float, and then call the correct conversion function based on the contents of the sound. And being able to just say match on those three values, and then here are the cases that we can handle, and then there's a fallback for the cases that we can't handle, is very pleasant to use. And I really enjoy this style of programming. Things that I love about Rust, number 2. So Cargo is the standard entry point for your project. It's the main tool that you're using when you're dealing with Rust. It's the build system, it's the dependency manager, it's the command you use when you want to run tests or open your documentation. It's a really powerful tool. And the fact that it's the standard tool that's used by default when you're dealing with a Rust project means that you get very familiar with it, and everyone else in the community and ecosystem is very familiar with it. So it's really nice that this is the default thing that is available from the start. So if you're looking for a library to integrate into your project, so for example, we need a WAV decoder. There are a collection of libraries out there that do WAV decoding. You can quickly find one of those libraries just by a simple search on the command line, or you can go to the website and then you can see all the links to the GitHub repos, etc. And you can audit, find a project that you think would work for you. And then adding it to your project is trivially easy. So you just list it as a dependency in your cargo.toml file, which is your project settings. And that one-liner will cause Cargo to download that version of the software, compile it, make it available in your project. And then in our load sample function, WAV-reader is coming from a use statement. We're saying use hound WAV-reader. And that's literally all you have to do to integrate like this really nice library into your project. Things that I love about Rust number 3. So traits are this like core concept in Rust of how you define interfaces for different types. And they're used for both compile time generic interfaces like C++20's concepts, and they're also used for runtime interfaces like virtual base classes in C++. So it's the same concept for both types of behavior, which is quite neat. And an example of how they look. So in the engine, in the Granular engine, there's a lot of linear interpolation going on. So we have a lerp function, and here it's implemented just for floats. So F32 is the 32-bit float type, and we have A and B as values, and we want to interpolate between them with an X factor. And that equation works out to give you linear interpolation between A and B. And that's nice, but it only works for floats. If you want to make it generic in Rust, it's very similar to C++ in that you use angled syntax, and then you have types that are available through your function. And we're going to take A and B as types T, and then have a separate type. Well, that's a type, that should be X. A separate type for the interpolation factor. And that allows you to have your custom types, but then have a scalar value for interpolation, which is quite useful. And then in a generic context, where you're making use of the types, so in this case, we're performing arithmetic operations on the types, you need to spell out in the function, in the context of where the types are defined, what traits you expect those types to implement. Now, it could be that T implements many other traits. It doesn't have to only implement these traits, but it at least will have implementations for these traits. And you say that T can be added to itself. So the add trait, like for T, the sub trait for T, that's subtraction. Mul, here we're saying that we need to be able to multiply a T by an X and then receive a T as an output. And that's what you see here. B minus A in the interpolation gives you the range size, and then you multiply it by the interpolation factor. And that B minus A would give you, your T type, and X would be the interpolation factor. Plus copy, which maybe is a detail we don't need to go into, but we do need to be able to copy A in this context. So we have to tell Rust that we need to be able to copy this value. Now, the value type that we're most interested in interpolating in this engine is a stereo frame. And that's because we have left and right channels for our grains. And we're going to perform the same operations on both the left and the right channels all the way through the pipeline. So we read a frame from the audio data in memory. We read a couple of samples out. We interpolate between them to get our interpolated readout. Then we're well, what are we doing? Oh, we're windowing the data, and we're mixing between two different sounds, and then we're applying panning and gain, and then we're mixing all of these gains together, and all of these operations can happen at the same time on the left and right channels. We don't have to spell out these operations on left and right independently. And we can achieve that by having this stereo frame type, and it's declared as a wrapper for an array of two floats. We don't need to go into the details of the syntax, but it's really we're declaring the stereo frame as a wrapper type or a new type in Rust terms. And here derive the attribute. This is an attribute which tells the compiler to automatically derive implementations of these 3 traits for the stereo frame type. So we get implementations of clone, copy, and default. And I included default here because it's useful to see that default now is available as a method or a function on stereo frame. So these traits aren't just about arithmetic operations or operators. They're about all kinds of behavior, including functions. If you want to go further with this and implement other traits that maybe can't be derived automatically, then you can implement that trait using this kind of expression where you say implement add for stereo frame, and then you explain to the compiler how to fulfill the interface of that trait. And here we're saying that the output is self, and this is shorthand for the type that you're implementing. So this is stereo frame. And we're implementing a function which is add, and we're going to get self, which is an instance of, well, it's a copy of this value. It's like this pointer in C++. And we receive another instance of stereo frame. And then we're going to add the 2 inner values together. So 0 here is the inner value, which is the array. And they get added together, and we end up with an added stereo frame. The same applies for subtract and multiply. The really only difference here is the operator that's used. The operator is already available for the array type. And the maybe more interesting case is the scalar multiplication. Here we declare that we're implementing multiply of F32 for stereo frame. And so then here the other type is F32. And in this case, we need to access the 2 channel elements independently and then multiply those together to produce our inner array. Now that's everything that we need to be able to use lerp with the stereo frame type. We now, well, I've added here an implementation which isn't attached to a trait, but is attached to the type itself. So now I'm adding a new method with a function, which is an idiomatic initializer function. For, well, in Rust, you generally implement a new function. And that allows us to show that lerp actually works here. We have 1 and 2 as our A value and 2 and 3 as our B value, and then we interpolate by half, and you'll get values halfway in between for each channel. Now you might be thinking there's a lot of parallel operations happening here on left and right channels. This could be a good opportunity for SIMD optimization, and you're right. And it is maybe useful to talk about SIMD in the context of what's changed since 2018, because in 2018, there were x86 intrinsics got stabilized, and it looked like there was a good progress towards stabilizing a high level abstraction over those intrinsics. But that effort stalled. A new effort is happening now to try and get some more SIMD functionality into the standard library. But that's underway, and there's a lot of problems to figure out there, and people are working on it. However, if all you need is simple arithmetic on F32s, and you're happy with x86 intrinsics, which I am, then there is a library called Wide, which offers a simple pack of 4 F32s as a SIMD type with implementations of all of the arithmetic traits, wrapping the underlying intrinsics. So the plus operation maps to the underlying intrinsic for add for 4 F32s. And then making use of that, instead of our array here that we're wrapping, we're instead wrapping an F32x4. And then in our new initializer, we're putting our left and right channels into the first and second elements, and then we're just zeroing 3 and 4 because we only, in this case, care about 2 channels. Then the implementations of the traits all come for free, except for the scalar multiplication, because the authors of F32X4 didn't add a scalar multiplier, but that's okay. It's easy to implement ourselves just by changing the implementation of the scalar multiplier to take the scalar factor and then construct an F32X4 from it. Then that's everything that we need to have a SIM-defined pipeline, because we're using stereo frames all the way through the like the grain processing and then into like the mixing of the grains. We end up with like SIMD pretty much all the way, and then that results in about a 30% speed up, which is nice. And I wanted to highlight this because I think the clean nature of how the traits are designed, and they're very clearly expressed and easy to implement, means that you're encouraged to create these kinds of abstractions. So really, for me, achieving simplification of the processing pipeline with a very small number of code changes was like a nice surprise, and that for me really fell out of just the nature of the design of traits. Number 4, no, I'm not sure how I'm doing for time, but I'll try and speed up a bit. The ecosystem in Rust is really nice. I think the fact that you have this standardized way of sharing packages means that there is a lot of sharing happening, and there are lots of libraries out there. And what I've seen in the last couple of years is that the quality of these libraries is increasing rapidly, and there are some really amazing projects popping up now. And particularly CPAL for audio had a lot of effort put into it in the last year, and this is a solid, like nicely done audio library like RT Audio or Port Audio, and I integrated that into this project really easily. DASP is a nice emerging collection of useful DSP utilities. It's well worth checking out. MIDI-R just worked, a nice cross-platform MIDI library for real-time input, and then WMIDI for like the MIDI types. Crossbeam makes cross-thread communication in Rust really easy. So Crossbeam channel is a subcrate, and I'm using that for MIDI to audio and audio to UI communication, and it just works really well. And Criterion is worth looking at if you're interested in benchmarking. It's a nice statistical benchmarking framework. So the last thing I want to mention about Rust is the feeling that I get with the Rust safety net. And I completely accept that the strictness of the compiler takes a bit of getting used to. It is pretty strict, and especially if you're coming from C or C++, you might find like this feeling of banging your head against the borrow checker. This is something that like I felt certainly at the beginning, and often it comes from trying to apply a pattern that you would think works in C++, and maybe it does work, but you aren't able to prove to the compiler that it can work safely. Like maybe it only works by chance, or because you've thought about it carefully, but maybe you've made some mistakes and you don't know, which is where these security bugs come from. And I described the feeling of it as like having a couple of like expert engineers looking over your shoulder as you're coding, and like telling you don't do that. Like you don't want to do that. Oh, have you thought about this? Or like, you know, it's this sense that you've got like experts with best practices pretty well thought through in the compiler. And that might sound daunting at first, or maybe even like oppressive or something. But I think that once you get used to the Rust way of working, and you get used to the tools that are available to you, and you find your feet a bit in the system, in the language, then for me, I found that it's really quite liberating, because once you have like a good sense of how to achieve the high level goals of your project, then you don't have to worry so much about the low level details. The good, well-designed architecture kind of emerges naturally if you follow the path of least resistance. And then when you do need to worry about the low level, like if you're optimizing or if you're taking care of some very specific functionality, then you can zoom in and then really care about those low level details. But the fact that you're able to shift levels of abstraction, for me, like seems quite natural now that I'm more experienced with Rust. And in the end, I think that this idea that like there's friction to the borrow checker, actually, for me, I find that in the long run, it reduces friction, and that's worth pointing out, I think. So then, in conclusion, what am I saying? I'm saying that I feel different when I use Rust or I program in Rust than when I'm programming in C++. And the sense I have is that it's a more pleasant language to work in for me. And that's not going to be true for everybody. And for some people, C++ is a natural language for them. And if you love C++, that's great. And I wouldn't want to change that, and I wouldn't suggest changing it at all. It's fine. And if you're comfortable in that environment, then that's great. But we're at the point now where alternatives are available, and it could be that Rust is the one for you, and it's worth looking into. But yeah, so the theme of the night is alternatives, and they do exist now. So that's all I wanted to say. And if you want to reach out to me at all, then you can find me on Twitter or GitHub. And if you've got any questions about Rust, just hit me up. I'm really happy to answer questions, and anything you want to talk about, just let me know. Okay, so that's it for me.
Thank you very much, Ian.
Yeah, thanks, Ian. Yeah, actually, I have to say, like, specifically one thing that you said, I'm one of those people who are basically naturals in C++, I guess, because that's what I've been doing all my career. But I wish I had experts looking over my shoulder, checking things like dangling references and things like that. So that actually would be great.
Yeah.
I do have one question, actually. So what I hear about Rust from other people, and particularly people who do like DAWs and plugins and these kind of things, is that you mentioned we have quite a few libraries now available in Rust. But what people say they're kind of missing before Rust becomes like a really viable alternative to them is like something like Qt or Juice, which is like an application framework, which brings all the GUI tools and all the other ancillary tools around it in one package to put together an app. And even more so, if you're doing plugins, you need something like Juice, which also gives you all the wrappers for, VST and audio unit and AX. And before we have that, we can't really, in this particular sub-industry, I would say, of the audio industry, we can't really use it like at all. But maybe we're missing something. So what's your opinion on that?
Well, I think you're right that Rust doesn't have yet a large-scale application framework like Juice or Qt that measures up against those frameworks at all. I mean, they're pretty mature and long-running projects, and Rust doesn't have anything like that. That said, there are projects that are emerging in different domains. So, like game engines are emerging, which are starting to look more and more attractive, and I think it's only a matter of time before the people who get invested in audio and Rust will start to build out the tools that you need to get a full stack of utilities that you need, right? Like, it's only a matter of time, I think. However, something that I showed in the ADC talk was that if you did want to go down the road of having those expert engineers on your shoulder applying best practices to your audio engine for an audio project, you could still use Juice as your application framework and then hook into Rust via the like C bindings. which is something I showed in the talk. You're able to compile Rust code with a C interface and then make use of that in any other application that would accept C code.
Great. So I have a load of questions here. And if you've answered any of these in here already, please just let me know, because I was just concentrating so much on the questions. So there's a comment from Cass Cassette who says, the pattern matching reminds me of Scala. Do you have any comments on that? Do you know anything about Scala?
Yeah, so the designers of Rust had a lot of functional programming in their background, and I think ML is one that's cited quite regularly, and you'll see similar patterns in lots of functional languages. That's definitely a big influence. I'm not sure of Scala specifically, but those kinds of ideas of how to deal with values, it pops up a lot in different functional languages.
Okay, great. James Bradbury asks, what is the worst part of coding with Rust compared to other languages? I'd be interested in knowing the pain points you have had either in practice or conceptually.
Yeah, I think so. The immaturity of some important libraries has been touched on already. So it would be great if we did have juice for Rust. That would be lovely. Mm-hmm. The two main gripes I have at the moment are compile times. And what I'm finding is that actually Rust doesn't compile slowly. It's not a slow language to compile by default. What you get, though, is that there are important libraries in the ecosystem which use procedural macros, which can then have explosive effects on your compile time. So you'll find that lots of projects take a minute or two to compile, and that's because they're using specific libraries that use specific features. And if you're careful about the way you construct your project, then you don't have to have slow compile times. So my wish for the community over the next few years is that there's a big effort to try and avoid these like really slow features. I mean, it's like in C++ with template metaprogramming, you can get constructions in your code that cause the compiler to lose its mind. And the same kind of thing is happening in Rust, I think.
Okay, great. And I think we've addressed this question a bit, but and there was one that was mentioned in the chat already, but Jose asks if there are any good libraries that you know of to start experimenting with Rust audio applications.
Yeah, I would recommend checking out Nanu, and it's spelled N-A-N-N-O-U. It's a creative coding framework which is similar in nature to open frameworks or Cinder. And it's really nicely put together, and lots of great examples to work from. And it has a simple audio abstraction, which is based on top of CPAL. So you can hook into an audio callback and get some audio going with a good graphical environment to play around in as well.
Great. And Guilio Moro asks, do traits have to be specified? Can it not infer them from the code?
So it could, but then you would have the same problem that you have in C++ pre-concepts, where you maybe you have a very long function that's generic, and then 50 lines in to the function, there's an operation that needs to be performed with your generic type that then causes a compiler error. And then you end up in a difficult situation where you're trying to figure out what went wrong. And what's much cleaner is that before any attempt is made to compile the function, the contract is checked. And if your types match this interface, then the compiler will continue. If not, then you get a really good, clear error message explaining why exactly your function won't compile.
I see. Okay, great. And I think this was more or less the point of your presentation, but let me see if you have any other thoughts. Stesian asks if there was anything that eventually made you decide to go with Rust for full-time development, and what took away some of the final doubts?
So I think a lot of the things that I mentioned really have attracted me to Rust. There's a lot more that I could talk about, but obviously we're short on time.
Okay.
I think if I was I don't know, like if I was working in a different area, like if I didn't have like freedom to choose exactly what I work on, then maybe I would be making more pragmatic choices. Mm-hmm. So if I was starting a plugin company today, maybe it's very likely that I would be using Juice, and then maybe I would make a choice about whether or not to use Rust for audio or some parts of the stack. But also maybe in the end, we would take a pragmatic choice to stick with C++ there. And that would be sensible and probably wise. But because I'm at a point in my career where I can try out a few different things, it seems to me that Rust has a very strong future ahead of it, and I'm quite happy to be engaging with it for now. Yeah.
Great. Another question from Guilio. What guarantees does Rust make as to memory allocation and in general real-time safety?
Yeah, it doesn't have a garbage collector, which is one of the main things that made it attractive to me in the first place. I for some reason, have a difficulty with languages like D, where the core of the language was designed around having a garbage collector in place. And this might be completely unfair, and I don't know if it's like a valid like concern, but what really like turned the lights on for me with Rust was that this was something that they made a choice on very early on, that they wouldn't have garbage collection. So then the guarantees, I mean, as far as I know, they're essentially the same as in C or C++. You have a like I think it uses the system allocator by default, and well, I didn't know we had lights in here. I've been in the dark the whole time. Yeah, it's basically the same, and then you can override the allocator. So if you want to have a custom specific allocator with specific properties, then you're able to do that if you want.
Great. And I think you might have addressed this a little bit as well in your presentation, but what control do you have on memory copy when passing arguments into a function, i.e. passing by reference or pointer versus passing by value?
Yeah, that's something I didn't touch on, which is that Rust is moved by default. Okay. So when you pass a value in, it is moved. Okay. If you implement copy on that value, then it will make a copy. If that would be a problem, then you pass by reference. And there it's essentially pointer semantics, except for the strictness of the Rust system, where you can only have one mutable reference at a time. You can have as many immutable references as you like. So you can share data around as much as you like in your system, as long as it doesn't change. And if you need to change it, then you have to have the only reference to that data.
Okay. And there's a question from Studio 6+1. With the stringency of Rust, does that mean that Rust no longer requires any sanitizers?
Well, now, I don't know if I would go that far. If you have a safe only project, then maybe that's enough. Mm-hmm. If you're using third-party libraries, maybe those libraries use unsafe internally, and they might claim to have a safe abstraction over the unsafe code, but maybe you're in a position where you don't want to trust them, and then maybe you would want to throw all of your analysis tools at that library as you can. I don't know. I haven't ended up in that situation, but there is an aspect to the unsafe versus safe concept where you have to trust the unsafe code. Mm-hmm. And in the case of like the standard library code, obviously this has been thoroughly vetted, and you can trust that it's correctly written. But in the case of third-party dependencies, you have to be cautious.
Great. So Spencer asks, and I think you've covered this, how is Rust ecosystem support for building cross-platform UIs? That's one of the weak points of Rust at the moment. Is that right?
Yeah, there are a few projects that are active that are trying to build a nice UI system for Rust, and there are a few around that are that you could look at. It seems that most projects will end up using GTK or Qt. So there are wrappers for Rust for Qt or for GTK. Mm-hmm. And I think that's what people would normally use. But the way so I haven't thought about this in a while. Before, I was thinking it would maybe make more sense if you have an application framework to instead of trying to fit that application framework into Rust, you would do it the other way around. So you would have a Qt application or a Juice application, and then you would use Rust as a library that you would pull in. So then you have your full-featured UI framework, but you're using Rust in specific areas where you think it makes sense.
Great. And we have one more question. I think your presentation addressed this pretty well, but any other comments? What do you feel the need is or requirement for an alternate audio programming language? What functionality does C++ lack that other languages offer, such as Rust?
Yeah, the only thing that C++ lacks is the guarantees about memory safety. I mean, otherwise, it's like a fully powerful language, right? And within that, you can create all kinds of libraries and frameworks that fit the domain that you're working in and build up something that makes sense for you. So I don't think C++ lacks anything other than it's very easy to make mistakes. And if you want to go deep into the language and become an expert in it, then you're going down a path of learning the standard, which will be appropriate for some people, but not appropriate for many others. And then you're working within a subset of the language. And if you're in a good framework, like Juice is an example, where if you're working within the scope of a particular framework and you kind of play by those rules, then maybe you're going to be fine. And you won't have the kinds of problems that maybe we're talking about.
Okay, great. I guess we'll finish off with one of my questions, actually, in terms of education, because just looking at the syntax of Rust from my perspective, it looks very tough to me. And I'm just curious from an education standpoint, when you have a team, and this would be a great question that maybe you and Neil would probably be able to address in terms of education for developers and the threshold to get into something like audio development. Let's say in a perfect world where a Rust version of Juice existed. Do you feel that this brings the threshold for getting into this type of development even higher? Or do you feel that that once we have a working audio framework that's on the same level as Juice, but a Rust version, that that this will actually make the threshold lower or the same? Do you have any comments on that? My feeling is that Rust is a more teachable language than C++. I think the concepts in the end are simpler. There might be potentially a lower barrier to entry with C++, but not to writing C++ correctly. Like if you want to write C++ without making mistakes, then I think that's a harder hill to climb. I think if I was starting with a team of developers with no experience in, say, any systems language, then personally I would rather teach them Rust than C++.
Yeah, just to interject, I really agree here. Like on the one hand, why we use C++ is because we have all these libraries and frameworks, but I would also not definitely recommend to start with it. It's just so hard and gets harder as it grows. And I always make this joke that, C++ is growing faster than the rate at which I'm learning it. So I'm actually getting worse at C++ as the time progresses. And I think
that's very frightening to hear you saying that.
Yeah, and that's something I would say as well, that I think if you're interested in Rust, then you should just take a look. Like, it's a good learning exercise, and if you're going to be continuing to work in C++, whatever happens, then fine. You've learned a few things in Rust that will probably make you a better C++ developer.
Great. Okay, I think, we do have one more question from Mark Mossberg. Does Rust have similar binary compatibility issues that C++ does?
Yes, it does. There are discussions you can look at online about whether or not Rust should have a stable API, and it does not at this point. And yeah, I mean, I wish it did, but they've decided at this point they're not going to commit to a stable API. So you really need to go down to like C bindings if you want to have like dynamic linked Rust libraries.